In this session, we'll review how to verify that the Valleylab FT10 generator performs safely and accurately after service or during routine maintenance. The goal is simple: confirm that every output, alarm, and circuit behaves as designed. We'll follow the procedures from Chapter 6 of the Service Manual, focusing on inspection, power verification, and leakage checks. By the end, you should understand how to confirm electrical safety to IEC standards and ensure the generator delivers precise power for clinical reliability. Periodic safety checks are part of every preventive maintenance cycle. The goal is to verify that the generator remains both electrically safe and fully functional. Technicians confirm visual condition, grounding, and leakage limits. This process aligns with IEC 60601 standards and manufacturer guidance. Each test protects patients and staff from possible hazards like insulation failure or poor grounding. Think of it as a structured routine to catch small issues before they become performance problems. Testing begins with proper setup. Place the FT10 on a grounded static safe bench. Attach a calibrated 100 ohm lead to the output port. This simulates surgical conditions. Connect a high-frequency analyzer to measure output power and a leakage tester to assess electrical safety. Confirm all instruments are within calibration date. Setup accuracy is critical because the data you gather depends entirely on stable connections and reliable reference equipment. Start with a detailed inspection. Examine every cable and port for wear or discoloration. Look for cracks, corrosion, or liquid residue that could signal fluid intrusion. Test the activation switch and foot switch for smooth, responsive operation. Visual checks may seem simple, but they often reveal early signs of wear or overheating. Document all findings before moving on to electrical testing. This baseline helps track long-term reliability. When the FT10 powers on, it automatically runs internal diagnostics. Watch the progress bar and ensure the boot sequence completes without error codes. The screen and audio should respond immediately. These checks confirm the microcontroller, sensors, and user interface are functioning properly. If you see any persistent alarms, the test sequence stops here until resolved. A clean startup indicates that internal systems are stable and ready for calibration level verification. This test confirms that the generator's actual output matches its displayed setting. In service mode, open the RF output test screen, apply the 100 ohm lead, and record power at several output levels, typically 30, 100, and 300 watts. The measured values should remain within 10% of the set point. Deviations may indicate calibration drift or internal board faults. Accurate power output is essential for predictable surgical performance. The Return Electrode Monitoring System, or REM, ensures proper patient contact. Using your analyzer, simulate both normal and disconnected conditions. The FT10 should immediately detect the change, displaying a warning and blocking activation. Then, test each output channel to confirm isolation, known as cross-coupling prevention. These steps validate patient safety and confirm the generator can detect electrode faults accurately. Leakage and grounding are the foundation of electrical safety. Use a safety analyzer to measure both ground resistance. It should be below 0.2 ohms. Next, check both low frequency and high frequency leakage. The high frequency leakage must stay within 150 milliamps, while chassis and patient leakage follow IEC 60601 limits. These results prove that insulation, shielding, and grounding paths remain intact, preventing any current from reaching the patient or operator. After all tests pass, complete the service record. Includes serial numbers, technician signatures, calibration references, and measured values. A proper record demonstrates compliance and accountability. Once verified, attach a service verified label with inspection date. This documentation is more than formality. It ensures traceability and provides confidence that the FT10 meets operational standards for clinical use. Every maintenance session ends with confirmation. The FT10 must perform safely, deliver accurate energy, and meet all electrical standards. Regular testing identifies small faults before they affect patient care. If a reading falls outside tolerance, recalibration or service intervention is required. Consistent testing isn't just regulatory, it ensures reliability, accuracy, and the continued trust placed in the surgical system.